Have you ever wondered why some race cars have wings? I mean, wings are for flying, aren't they? They make sense on a plane or a bird, but why would a car need wings? Well, let's just think for a moment what a wing does. Its job is to provide lift, and it does this in two ways. Firstly, if we tilt it up slightly, then place it in fast-moving air, it will deflect some of the air down. This produces an equal and opposite reactive force, which tends to lift the wing up. Simple really. More tilt gives more lift. Secondly, most wings make use of something called the Venturi effect. Shaping the wing so that it is more curved on top than underneath means that air flowing over the top of the wing needs to travel further than air flowing under the wing. The result is that air travelling over the top travels faster. Faster moving air has lower pressure than slower moving air. This is the Venturi effect. The resulting pressure difference between the top and the bottom of the wing effectively sucks the wing up, and thus generates lift. The greater the curve in the wing and the faster the air, the greater the lift. Okay, that's great for a plane, but what about a car? Well, in fact, ordinary cars don't need wings. So let's focus on race cars. Race cars need to be fast, but how do we make a car faster? Well, a bigger engine helps, but at some point the car will need to get around a corner. Cornering really fast takes a lot of turning force, and this comes from the grip between the tyres and the track surface. The more grip the car has, the faster it can get round corners. One way to increase grip would be to make the car heavier, but that wouldn't do much for its acceleration, and this is where the wing comes in. By turning the wing over, lift becomes downforce. By placing upturned wings on the front and the back of a race car, the downforce will push the car down into the track. This increases grip without making the car heavier. The faster the car travels, the greater the downforce and the greater the grip. Did you know that a Formula 1 car can generate more than 1,000 kilograms of downforce? And since an F1 car only weighs about 650 kilograms, this means that it could, in theory, be driven upside down. Great, but there is still one problem. Where there is downforce, there will also be drag. The greater the downforce, the greater the drag. The drag, of course, will slow the car down, especially on the fastest sections of track, which could undo all the good work. So wings must be a compromise. Better for corners, not so good for straights. They must be set very carefully by the race engineer to suit each different track that the car will race on. However, Formula 1 cars have one more very neat trick that can help. It's called DRS, or drag reduction system. For DRS, the rear wing, which is the biggest one, and therefore the one that causes the most drag, is made in two parts. The front part is hinged here, and the back part is hinged here. When the two parts are set so that they're aligned like this, they act as one large wing, producing a lot of downforce, but also a lot of drag. This means that the car is very fast around corners, but it will slow the car down on the straights. However, F1 drivers have a button that they're allowed to use on certain fast sections of straight track. The button moves the rear wing sections so that they rotate on their hinges. The wing splits into two parts with reduced angles of attack. There is less downforce, but also much less drag. It allows the car to travel up to 20 km/h faster, which is great for overtaking. And that is why race cars have wings.